So if you can't log in during a regular class period, remember if you go to classwork, there's that class documents, and the very first thing is my YouTube link, and it will have the most recent video at the top. The video will include the homework for the day. One other place you can go for your homework, remember under Chapter 1, there's the assignment tracker. And that has every day what we're doing. You know, Friday we started section 1.4, you had those book problems. Today I'm still working on section 1.4. You're going to have a handout that I'm going to post. So you can look there for your homework as well. In general, I probably will not post every single day with your homework on Classroom because there are a couple places you can go, the video or the assignment tracker, to get that. If it's a handout or something, like this morning I did have a post with the handout for today, I will put those up, but otherwise don't expect me to make a daily post. Any questions? Were there any issues Thursday and Friday when we were online? Did you guys find your work and videos worked okay and everything? Then we are ready to start. Friday, we were working on section 1.4, quadratic equations. We talked about solving them by the square root method and by factoring, and I think my video left off, I had you write this down in your notes, but I hadn't done any examples yet. So this is where we want to pick up today. So sometimes we have quadratic equations that factor nicely. We could do the box method or something and get an answer. Then other times we have quadratics that don't factor at all, and we need another strategy. Completing the square is usually not anybody's go-to method, but I'm going to go ahead and teach it because later on when we are talking about graphing and transformations, we have to have this strategy then, so now is a good time to go ahead and review that. So the steps that we wrote down last week. In order to complete the square, you have to have a leading coefficient of 1. So if it's anything other than 1, you had to start out by first dividing by that thing. Second step was to isolate the constant on one side, everything with the variable on the other. Then we basically built a perfect square so that we had a problem we could solve with the square root method. Easiest way to really understand this is just to work a problem. So let's try that. If I am looking at this, x squared minus 4x minus 14. If I try to do box method, is there anything that multiplies to negative 14 and adds to negative 4? No. So box method wouldn't work even if I wanted it to. So first step for box method says the leading coefficient has to be a 1, which this is. Second step says you isolate the constant. We are going to add that 14 over. And when I rewrite this, I'm going to leave a little space here. Our goal is to create a perfect square. When I say a perfect square, I'm talking about something like x plus 2 squared. If you FOIL that out, you get x squared plus 4x plus 4. If I did x minus 3 squared, when you multiply that out, get here. If I said x plus 4 squared, x minus 5 squared. if you look at these, can you tell any relationship between like the 25 and the 2? Or the 16 and the 8? How are those things related? If you look at our steps, it says you're going to take half of this middle term and square it. 10 divided by 2 is 5, and 5 squared is 25. 8 divided by 2 is 4, 4 squared is 16. 6 divided by 2 is 3, 3 squared is 9. So that's what we're going to do to build this perfect square. We take our middle term, which is a -4. We divide that by 2, and then we square it. So -4 divided by 2 is -2. -2 squared is +4. But it's an equation. I don't want to change my problem. So if you add 4 to one side, you have to add it to the other as well. Okay. Now we can factor. This is a perfect square, so it should factor into something squared. We have an x. There's a few different ways you could get this number. If I look up here, there was a subtraction, so we need a subtraction. What's the square root of 4? 2, so it's x minus 2. The suggestion I always give people, look at your number before you square. When we did -4 divided by 2, we got a -2, so it's an x minus 2. Over here, 14 plus 4 is 18. Now if I'm trying to solve for x, we have to get rid of the square, so we add a square root. Anytime you add a square root in the problem, what else do you have to put? So on the left, the square root and square cancel each other. Okay, I need to break down the square root of 18. What perfect square goes into that? Hmm? 9. 18 is like a 9 times into 2. So that's 3 radical 2. Okay, next step, get the x by itself, so you add your 2. So x equals 2 plus and minus 3 radical 2. I don't want a decimal answer. I want exact answers all the time unless I specifically tell you otherwise. So that means we're going to leave this in terms of radicals. These aren't like terms, so I can't actually add them. That's it. Let's try a couple more. I think I'm going to change my order here a bit. Let's do this one next. So if we try to factor it, is there anything that multiplies to -2 and adds to -2? No, so it couldn't be factored even if we wanted to. So completing the square is our best option. First step, it has to be a 1x squared, and it is. So we get to go to the second step, which is move the constant over. leave yourself a little space. So I add my 2. Now, to make our perfect square, what do we have to do? 2 things. Take my middle term, which is that -2, and every time you will divide that by 2 and then square. So -2 divided by 2 is -1, -1 squared is +1. So we add 1 to each side. Then we can factor. We just created a perfect square, so this will factor into something squared every single time. We have our x. Easiest way to get it is just look before you square. -2 divided by 2 was -1, so it's an x minus 1 squared equals 3. To get rid of square, you need a square root. With that, you always have to do a plus and a minus. So those drop. We have x minus 1 equals plus and minus radical 3. Final step, to get x by itself, add your 1 over. They aren't like terms, so we just leave it as it is. If they were like terms, if it was 1 plus or minus 3, I do expect you to go ahead and simplify that and do 1 plus 3 and 1 minus 3 and get your 2 answers. Is that one okay? Let's do one more. Look at this one. This is actually example C. Skip one. Okay. So first step says we have to have a leading coefficient of 1. My leading coefficient right now is -4. So to fix this, we have to divide everything, every single term, by -4. So that gives me an x squared minus 2x equals -7/4. And it's okay to have a fraction in there. Next step is to move over the constant, but we actually don't have to because the constant is already on the side by itself. So we're going to build our perfect square. We take our middle term, which is -2. We need to divide that by 2 and square it. So -2 divided by 2 is -1, squared is +1. So this side should factor into x. Before we squared it was just a -1. -7/4 plus 1, like -7/4 plus 4/4. That's -3/4. Cancel the square, so square root, plus and minus. So x minus 1 equals plus and minus. With a radical, you can't leave a radical in the denominator. So I'm going to separate this. What's the square root of -3? Yep. Because of the negative, you have to take out an I. Do you guys remember that? That was from Thursday's video, I believe. And we just can't break down the square root of 3. Over the square root of 4 is just 2. So add our 1 over, and our final answer is x equals 1 plus and minus I radical 3 over 2. So it's okay to have imaginaries. Do you need more examples with completing the square? Next thing that I want to mention. So completing the square always works. There's one other thing that always works when you're solving a quadratic, and it was probably the thing you preferred, quadratic formula. So you want to write this down. This is, I don't make you memorize many formulas, but the quadratic formula is one you should know because it shows up so much. We will use it all the time in here. So x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This can be used to solve any quadratic that I can give you, but it does have to be written a certain way. You have to have the quadratic on one side and set it equal to 0 for it to work. A, B, and C just represent your coefficients, A being the coefficient on your square term, B is the coefficient on your x term, and C is a constant. So we'll try one or two of these. If you guys remember it, then I probably won't do too many examples. Let's say I gave you that one. What do I have to do before I'm going to be able to do the quadratic on this? We have to add our 2. We just need everything on one side. So if we add that over, so what's our A value? 1. B is, and C is. So x equals the opposite of B. So B is -4, so the opposite of that would be 4. Plus or minus the square root of b squared minus 4ac all over 2a. Okay, go ahead and simplify that. So under my square root, I get 16 minus 8, which is 8. Break down the 8, break down to a 4 and a 2. So 4 plus and minus 2 radical 2 over 2. Cancel a 2 everything, so you should have gotten 2 plus and minus the square root of 2. Do you need another quadratic formula example? Are we good? Not good? Give me something. Good? last thing I want to mention then, sometimes I don't care what the actual solutions are. I just care what they're going to look like. So I might ask you about the discriminant. The discriminant is that thing that shows up under the radical. So in the quadratic formula, it's the b squared minus 4ac. It doesn't include the square root, strictly that portion underneath. And we can tell what our answers are going to look like just based off that number. If it's a positive number, we can do the square root of a positive number. So you get two different real solutions. So if our discriminant is greater than 0, there are two unequal real number solutions. If it is equal to 0, then you have plus and minus the square root of 0, which gives you the same thing. So you only get one repeated solution. And in the case where it is negative, that's when the I comes into play. So you get two different imaginary solutions. So I'll give you a minute to write that down before we look at one. So if I just said, find the number of real solutions to this. So I didn't ask you to actually solve it. On the test, I might even say use the discriminant to determine, just to be very clear about what I'm asking. So we don't have to do anything except what would show up under the square root if we did the quadratic formula. So all we need is b squared minus 4ac. So my b is a negative 5 squared minus 4, a is 3, and c is 1. So my discriminant is 13. What does that tell me? It's basically two real, two imaginary, or one repeated real one. If it's positive, what that means? Two real. One more. I'm going to make that a negative 1/2 squared. Okay, so before I can do anything, I have to set this equal to 0. Bless you. So add over our 1/2. Then b squared minus 4ac. So our b is negative 1/4 squared minus 4. A is 3/4 and c is 1/2. So we get 1/16 minus 3/2. And remember, if you guys need a calculator, either you can have your own or you can use the graphing one in your Chromebook. And we get negative 23/16. So what does that tell me? If it's negative, they are imaginary, two imaginary. Any issues with anything? So, your assignment today, and I'm going to talk about the next couple days for you. There is a handout posted in Classroom. Make sure you're following the directions. The first few I say use either the square root method or factoring. Then there's some I say use completing the square, some that tell you to use the quadratic formula. So I have you practicing every technique, use the directions. Tomorrow, I am going to start section 6, and we're actually skipping section 5 in your book. So I'll start section 6. Please either join in class in the Google Meet or watch the video. That section is going to have several different types of problems in it. So we're going to be solving some equations involving fractions and radicals tomorrow, and there'll be an assignment. Wednesday is our complete online day, and what I have chosen to do this week for that is I'm going to give you a quiz, because it's not technically like a regular quiz because I'm letting you take it home and do it. But you will turn this in on Thursday, and I will grade it like I would grade a quiz. So you have to show me all of your work on everything. This only includes sections 1 through 4, so not the part I'm teaching tomorrow, just what we've covered up until today. So I'll go ahead and give this to you. And then on Thursday you'll have your 2 book assignments and this quiz to give. And you have quite a bit of time right now to get started on that handout and ask me questions. Yes. Please, when you're working on this homework, if you get stuck on anything, let me know.